Hello students, firstly I welcome all of you once again to this class. Today we'll be starting a new chapter, that is chapter 12, direct and inverse variations. Okay, before we come to the chapter, let us know a very important term that we are going to use in every question in the whole chapter. We are talking about quantity. What is meant by quantity? Quantity means anything that can be measured. It may be number of boys, it may be number of girls, it may be number of people, it may be number of liters of petrol, it may be number of pens, it may be number of shirts, it may be the length of the thread. These kind of things, these are actually quantities. Anything that can be measured. When I say number of dusters, we can even count the number of dusters. We can even count the number of glasses. We can count even number of laptops. These are actually quantities. So quantities in a sense like distance, when we measure the length of the between the 2 points, between the 2 places, this is also a quantity. Okay, fine. So here we are going to study about direct and inverse variations. In this chapter, what we're going to study is, we are going to study a certain type of relation that exists between the two quantities. How is the relation? I'll explain to you now. So let me just write here number of pens. Number of pens. You are going to the market and you buy the pens. Now you are buying 2 pens and you have to pay here 20 rupees. This is your amount in terms of rupee. When you buy 2 pens and you are giving here 20 rupees. Let us think that you are buying one particular type of pen. Let me say your Max Writer. Max Writer. And again you're buying 3 pens again, and you'll be paying here 30 rupees. If you buy here 1 pen, I'm sure you'll be paying here 10 rupees. Okay, so this number of pens is actually a quantity. So this number of pens, you can just write here quantity A, and this is your quantity B. Okay, please look at here. When the number of pen increases from 2 to 3, even the amount also increases from 20 to 30. So that means when there is a change in the quantity A, we find the changes even in the quantity B. So when from 3, when it decreases to only 1, even the amount also decreases. So here what we find is, when there is a change means it may be increase or decrease in quantity A, we find a change in quantity B. That means change means it may be decrease or increase. Okay, we are talking about, when I say change, it may be increase or it may be decrease. Both are changes only. That means there is a link, there is a relationship between A and B. When A changes, B also changes. That means these A and B are in variation. Let me repeat, these two quantities A and B. Here A means it represents number of pens and B represents the amount. Amount means in terms of money, in terms of rupees. So these quantities A and B are in variation. Okay, fine. Now I hope you understand the meaning of variation. Next, we're going to study about the types of variation. Types of variation. Here, types of variation. We have 2 types. One is direct, another is inverse. In case of the direct, what happened I'll show you. We have two quantities here A and here quantity B. When quantity A increases, quantity B also increases. When quantity A decreases, even the quantity B decreases. So let me repeat. If quantity A increases, quantity B also increases. If quantity A decreases, quantity B also, if quantity A decreases, quantity B also decreases. That means increase, increase, decrease, decrease. This kind of variation is what we call direct variation. That means we can say that A and B are in direct variation. So like before I gave you the example of the number of pens you buy and the amount that you pay, that is actually direct. If you buy more pens, I'm talking about the same quantity, same type of pen, same brand, same like cost of pen. I mean, let's say Max Writer pen. The cost of one pen is 10 rupees. Okay, fine. So if you buy more pens, you have to pay more amount. If you buy less pen, you have to pay less amount. That means when number of pen increases, even the amount increases. If the number of pens decreases, then even the amount also decreases. That is the example of direct variation. Okay, now there is something called constant of variation. I'll give the example now. I'll just make a table here. This is quantity A and this is quantity B. So you can just think that this A represents the number of pens and this B is the amount, the cost. So when we buy here 2 pens, we are paying here 20. When we save here 4 pens, then we have to pay here 40. What we understand is these quantities A and B are in direct variation. That means when you find the value of A divided by B, that means the ratio of A and B, how much we'll get here? 2 by 10. And how much we'll get? Again 1 by 5. Sorry, this is 20, so 1 by 10. Next, similarly you can find even the 4 by 40 also. Let me just write here A by B. Okay, nothing wrong. 4 by 40. So here also 4, 1 is 4, 40 and 40, so we'll be getting here 1 by 10. When we find the ratio of A and B, here also A and B, we get the value 1 by 10, 1 by 10. This value 1 by 10 is what we call constant of variation. Let me repeat. This value is what we call constant of constant of variation. Okay, in short, you can say even like this: A divided by B is equal to K. K means this 1 by 10. This K is what we call constant of variation. Okay, now we'll be moving to the next topic, next type, that is inverse variation. So in inverse variation, what happened is we are talking about two quantities here also, A and B. If quantity A increases, then quantity B decreases. When quantity A increases, quantity B decreases. If quantity A decreases, then quantity B increases. Now it's opposite actually. When one increases, other decreases. When one decreases, other increases. So that means these A and B are in inverse variation. So let me give you one example here. One example is, this is your home. You are coming from your house, from your residence, from your home to school every day. Sometimes you walk slowly. Then I'm sure you'll be taking more time. And sometimes you walk very fast. Then that time you take very less time. So that means here you walk fast, you walk slowly, that's actually nothing but that's your speed. That is your speed. And time taken, sometimes you take less time, sometimes you take more time. It depends on how much it depends on your speed, whether you walk faster or you walk slowly. It depends on that only. So when speed increases, time decreases. When when speed decreases, time increases. So now I'll give you one table here. Okay, here's the table. 1 2 3 4. Okay, fine. This is the speed, so let me write here 2 units, then here 3, then here 4, then here 1. So this is your 6 4 3, then here 12. Let's see here. Okay, when the speed is 2 units, time taken is 6 units. When the speed is 3 units, the time taken is 4 units. When the speed is 4, time taken is 3. When the speed is 1, then the time taken is 12 units. Okay, now let us see. When the value of speed, let me just represent here with the quantity A, and this is B. Okay, quantity A here is 2, quantity B is 6. We have to look at the corresponding values. 2 and 6 are corresponding values, 3 and 4 corresponding values, 4 and 3 are corresponding values. Similarly, 1 and 12 are corresponding values. Okay, when A is 2, B is 6. And when A is 3, that means here A value increases and here B is 4. When when the quantity A increases, the quantity B decreases. We have seen here, please have a look. From 2 to 3, that means it increases from 2 to 3, and then now it decreases from 6 to 4. And let's see here, now again increases, then again decreases. So when suddenly when A decreases from 4 to 1, then the quantity B changes. What kind of change here? B suddenly increases. That means when A increases, B decreases, and when A decreases, B increases. That means these quantities A and B are in inverse variation. Okay, so please have a look at here. Even here also we have constant of variation. How we are going to find the constant of variation here in case of the inverse variation? If you multiply, that means the product of these two quantities A and B will be always a constant. A into B will give you always a constant. So let's see here, 2 into 6 we have here 12. Next 3 into 4, 3 into 4 we have here 12. Next 4 into 3, sorry, I think you cannot see this part. So here A into B is, okay, K. K means I'm talking about constant of variation. Okay, here 2 into 3, 2 into 6, you'll be getting here 12. And then 3 into 4, you'll get here 12. Similarly, even you find 4 into 3, you'll get here 12. 1 into 12, you'll get here 12. These 12 is what you call constant of variation. Okay, so let me just give the conclusion now. We have two types of variation. One is direct variation and other is inverse variation. Okay, now if A and B are in direct variation, then A by B is equal to K. That means A by B will be constant of variation. When A is divided by B, the value that we get will be the constant of variation. So in case of the inverse variation, then this constant of variation will be given by A into B. This is in case of inverse variation. Okay, now after this we'll be moving to the exercise. We'll be solving few questions. Okay, here is a question. I'll read the question for you. Here two tables are given below, are given. So actually they give us the two tables, but I'm writing the first one only as of now. Find in which table A and B are in direct variation. If A and B are in direct variation, then find the constant of variation. First we have to identify in which table A and B are in direct variation or not. The question is asking about the direct variation. So how are we going to check whether the A and B are in, the quantities A and B are in direct variation or not? We have to find the value of A by B. If the value of A by B for the corresponding values of A, if we get a constant value, if we get a fixed value, then A and B are in direct variation. So let's see. We'll solve now. Okay, I'll start the solution now. Let me just write here let us find the value of A by B. Okay, therefore this is 3 by 18. So 3 by 18 means we'll get here 1 by 6. Why 1 by 6? 3 1 is 3, 3 6, 18. So like that you can find even here 5 divided by 30. We'll get here 1 by 6 as well. Next is 7 by 42. So here 7 by 42. 7 6 42. So it will be again 1 by 6. Next is 9 by 54. 9 by 54. That means 9 1 is 9. 9 6 are 54. Okay, next we have 1166. Okay, I have the textbook, fine. 1166. So 11 divided by 66. So we have here 1 by 6. Then next 4 by 24. We have here 4 1 is 4, 4 6, 24. And next 6 divided by 42. 6 1 is 6, 6 7. Sorry, this is 6 by 42. Okay, so please have a look at here. 6 1 is 6, 6 7 and 42. This is actually 1 by 7. Okay, please have a look. If it is the mistake of the question, please pay your attention here. We are getting here 1 by 6, 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 1 by 6. Okay, now at the last the value of A is 6 and B is 42, and suddenly I'm getting here 1 by 7. Till the 6th, till here we are getting 1 by 6. But when you are finding the 7th one, we are getting suddenly here 1 by 7. That means these values are not actually constant. Till here it's fine, fixed, but suddenly when we find at last, we are getting here 1 by 7. What does it mean? It means that these quantities A and B are not in direct variation. Okay, please pay attention here. We do not get the constant value here when we find the value of A by B, the corresponding value of A by B. Okay, then that means A and B are not in direct variation. But please pay attention here. If the question give you, instead of 6 by 42, if the question give you 7 by 42, then we'll be getting here 1 by 6. In this condition, you will say that A and B are in direct variation. But since the question gives us 6 by 42, we are getting here 1 by 7. Because of this, these A and B are not in direct variation. Okay, after this we can write here the ratio of all the corresponding values of A and B is not constant. If you are getting 1 by 6 in all the cases, then you will say it's constant, but here because of the last part 1 by 7, they are not actually same in all the cases. That means it's not constant. Hence A and B are not in, I'll rub this part are not in direct variation. Okay, we'll move to the next question. Question B. Okay, here is the question. This is question number 1B. We are going to do the same process. Here, I'll start the solution. Let us find the value of A by B. Therefore, corresponding value of A and B, that means 5 and 35, 5 by 35. 5 1 is 5, 5 7, 35. So we'll be getting here 1 by 7. Next we have 9 divided by 63. 9 1 is 9, 9 7 are 63. So we'll be getting again here 1 by 7 as well. So next is 8 by 56. Here 8 by 56. So 1 by 7 again. Next we have 11 by, we left 7 by 49. Okay, I'll just find here 7 by 49. So we have how much? 1 by 7. 7 1 7 7 7 49. Okay, we'll move to the next part. We have done till first, second, third, fourth. We have the last 4. Okay, so here 11 by 77 equal to 11 1 11, 11 7 77, and then next is 12 by 84. 12 by 84. 12 1 12, 12 7 are 84. So the last we have 15 divided by 105. 15 into 1 15, 15 into 7 105. So we'll be writing here 1 by 7. So whenever we find the values of this A by B, we all get here 1 by 7, 1 by 7, 1 by 7 in all the cases. It means that I'm going to write here the ratio of all the corresponding values of A and B is constant. It's constant. Therefore, A and B are in direct variation. So if the question says very clearly, if A and B are in direct variation, then we have to find the constant of variation. Therefore, or just you can leave it, it's fine. Constant of variation equal to, when we find the ratio here A by B, how much we get here? 1 by 7. So the constant of variation is 1 by 7. Students, I believe that you would be learning today, and thank you so much once again for watching the video. We'll see you again soon.